Let us begin. So last week we finished off with question 1 and 2. Today we'll continue with 3. So 3, it says that a relational database is composed of the following 4 objects that all work together with the same data, so tables, forms, queries, reports. Complete each of the statements below using the most appropriate term from the list above. Any term may be used more than once. So a relational database stores data in a number of related fields, more commonly referred to as
reports,
nope,
tables,
So in a database, in a Microsoft database, if you ever go and study IT further, you're going to come across a lot more different terms like tuples and files and entities and a lot of fancy terms. But for basic database, the main storage of data, we say that is stored inside of tables. So 2, what are used to ask detailed questions of the database when searching for records that satisfy your particular condition?
queries,
So queries is like if you ask in the database a question, you want a particular view of the data. Maybe all persons who are older than 18, all males, all persons who live in Georgetown. So you're asking detailed questions to the database, and that is what a query does. It's basically asking a question. 3, what displays fields extracted from what in a particular order? A report displays fields extracted from
tables,
Now note, it could be tables and queries. Because I'm not sure if you guys can remember, but when you're working in database and you're creating a report, you can actually pull data from both a table and a query. So anything you're creating actually, if I go and create a form, notice it says table/queries here. So I can pull the data from a table or from a query. That there's a report. If I go to query wizard, so notice even from a query, if you're creating a query, you can pull the data from another query. So that's just a technicality. But mainly you would say you are creating the report to display fields extracted from the table, but it can also be extracted from the query. Because a query is technically pulling data from the table, but the query also has the ability to create new fields. And those fields that you create will not exist in the table. So that's why that functionality is there. I'm not sure if you guys can remember, but we have what is called a calculated field. And that can be done inside of a query, whereby you add 2 fields together, and you create a whole new field. So you add field number 1 with field number 2, and you get a whole totally new field number 3. And that field number 3 is not going to be stored in the table. It's only going to be in the query. So by only looking at that query, will you be able to see that field. So, but the main takeaway here is that report is basically when you are extracting data from a table. Last one, 4. What is used as a graphical representation to allow users to enter, modify, delete, and view records in the database?
Forms.
Forms. Correct. So a form is basically like a table, but just that it is a graphical representation of that table. Instead of seeing an actual table, because remember, a table is made up of rows and columns. A form is more graphical. When we say something is more graphical, in that we are seeing windows, we are seeing boxes, we are seeing color, we are seeing design, we are seeing those elements that give us a graphical representation, they would say. So anytime you see that description, it's a form we are referring to. Now, at the top here, they mentioned that the very first line, a relational database is composed of the following 4 objects. Now, in the database, whatever you create in the database, the major components, we call them objects. Now, here they mentioned 4 objects, but it's technically another one. Anybody know what's the other one? We didn't focus on it, we didn't learn it, but still good to know what it is. Anybody know what that one is? So that one is macros. So if you notice here, under the Create tab, we have all the objects here. So you have tables, you have queries, you have forms, you have reports, and lastly, you have macros. Now, macros is basically like if you are writing a program, you can say. You're writing instructions to tell the database to do something. Because if you notice, everything that we're doing is basically just click and drag and type, and it's not much like if you're creating a program, you can see. But the macro is more on that side, like if you're actually writing a program. But that won't be any exam, not part of the syllabus, but just let you know what it is. Any questions on question number 3 before we move on?
No questions.
All right. All right, so this is question 3B. Figures 4 and 5 are 2 database tables named customers and orders, respectively. So this is our customer table. This is our orders table. Now, figure 6 is the dialog box showing the relationship between the customers and orders table. So this is when you're creating a relationship, this box usually appears, and it's showing that connection between the 2 tables there. Now the question is, the entries in the dialog box in figure 6 on page 12 are used when joining the database tables, customers and orders, to establish a one-to-many relationship. Describe each of the following entries. ID. So we have to describe this ID field here. What description would we say about this ID field? I mean, go ahead.
I'd say that it's used to uniquely identify a particular customer.
Good. That could be one. The ID is used to uniquely identify the customer. Now that ID field, what table is it a part of?
Sir, the customer table.
Good. So we can also mention that the ID field is used to uniquely identify the customer in the customer's table. And I think that is about it, because the word uniquely indicates, oh, there's actually one more thing we can describe about this field. So that's one description there about this ID field, that it is a field used to uniquely identify the customer in the customer's table. But there's one more thing we can mention about it. One more thing. Primary key, correct. So let me. So ID field is used to uniquely identify the customers in the customer table. And a second description could be, but it's a one mark, but it's good to know how else we can describe it. The ID field is a primary key used to uniquely identify each customer in the customer table. So I think the last one would have been a more detailed description compared to the first. But basically, by saying uniquely identify, it's kind of an indication it's functioning as a primary key, but being more specific won't hurt. Yeah, so that's the description of ID. Now, what is the description of customer's ID? So that's customer's ID in this table here. No answers? Anybody thinking what to say, or let's go ahead and give the answer?
Sir, would it be a foreign key
Good.
from the orders table?
Mm-hmm. Continue. Or does it? Because you could add more.
And that is all I know.
All right. Anybody want to contribute to that? So it's a foreign key. What else? What else can you add to that description?
It's from the orders table.
Good. So it's a foreign key in the orders table. And what is it doing?
It's identifying different customers.
Good. So it's identifying the customers. So in this case, it's not going to be, it's still kind of uniquely identifying it, because a 1 is only going to be linked to one customer, a 2 is only going to be linked to a single customer. But just that customer now, ID, can be appearing multiple times. So the customer ID is a foreign key in the orders table used to identify the customer. Good. So with those two information there, 1 and 2, if you notice here in the question, it says that we're establishing a one-to-many relationship. So what two fields do you need to establish a one-to-many relationship? What two kind of fields do you need to create a one-to-many relationship? What two type of fields? The answers are right there. What two type of fields you need to get a one-to-many relationship? The answers are right there. Nobody's gonna try?
Sir, you would need a primary key and a foreign key?
Right, that's simple. So to get a one-to-many relationship, you need a primary key and you need a foreign key. That's how you get a one-to-many relationship. One field has to be a primary key and the other field has to be a foreign key. Because remember how the keys work is that the primary key ensures that the field only appears once. So like how you see in this table here, 1, 2, 3, 4, 5, 6, 7, 8, all the way to 10, those numbers individually only appear once. That's what the primary key does, ensure it's unique. But the foreign key, the purpose of that is to enable that field to appear many times. That's the purpose of that foreign key. To ensure that, to enable that field to appear many times. So they're not using any example here, but in this case here, we could have seen 12 repeating, we could have seen 14 repeating, and so on. Because that's the foreign side. So, but also note how this relationship works is that, say for instance, this table here does not have a 1. Say for instance, a 1 was never entered into this table here. How that relationship would work, or the purpose of that relationship, is that a 1 cannot exist in this table here also. Because it has to be firstly inside of the main table. It has to be firstly inside of the table that has the primary key. That's the only way it can exist inside of this table here at the bottom. And vice versa, if, like how in this case here, I entered the 1 already, I cannot go to this table at the top here and change this 1. It's going to form like a protected link. They're now like in a legitimate relationship. I can't just go and delete one side and expect it to disappear. And this is actually an important point because I don't know if they might ask you a question on it, but it's possible. But just know that this is the primary key side and this is the foreign key side. Now, what you can take note of here is which can you delete and which will be successful when you're deleting. So this one at the top, here, you cannot delete it. You cannot delete this 1 because it is existed inside of the orders table. But at the bottom here, you can delete it. In the foreign key table, from the foreign key, you can delete it because it's not a primary key. in that it's not being used in any other table. Because basically, you got to think about it logically. This one here at the top is the main one, is the main numbers, and those numbers are being used somewhere else. So if you go and delete from the top table, then what is this one at the bottom here going to mean? It won't have a meaning anymore if you go and delete it from the top. So the system does not allow you to delete it. So in this case here, you cannot delete from the primary key table once that field was entered inside of the other table. If it was a case that we did not enter a 1 over here, then we can go and delete it. We will be successful in deleting it. But the fact that it has a 1, we typed it, it can't just exist without the source. So it won't allow us to delete it. Think you guys understand that?
Okay.
So that's basically what the relationship does. That is why we enforce referential integrity. Now, and that's what the last question is asking here for question B. What is this referential integrity? What description can we give for that? What's this purpose of this referential integrity?
To the enforce referential integrity, it basically stops you from deleting the data or information in the primary key because that would affect the information in the foreign key.
Good. Anybody else? So what I'm more looking for is that enforce referential integrity. What word should I use? Let's use the word allows. I don't want to use the word allow, but I'm not thinking of anything else. Okay, so enforce referential integrity forces the relationship into a one-to-many relationship. So that's basically what the enforced referential integrity does. It basically forces, I don't want to use the word forces, but let me use the word makes. Yeah, it makes the relationship reinforced referential integrity makes the relationship a one-to-many relationship. What am I talking about there? So look at the actual situation. Now, let me delete this relationship here. So I'm deleting this here. Gone. Now, what was the relationship? If I go and try to create a relationship and I'm not going to enforce referential integrity, I'm just going to select create. Notice what happens. I only get a line. Now the line is indicating that there's a relationship, that these two tables are connected to each other. They're linked to each other. But if you notice, we do not know what type of relationship was created. Actually, the relationship doesn't have a type because we're not seeing any symbols. You know the type of relationship when you see the symbol. You see a 1, you see infinity. That's indicating one to many. So the purpose of enforcing referential integrity is to basically enforce a certain type of relationship, to make a certain type of relationship. So by checking this box and selecting OK, the system will automatically pick the appropriate type of relationship that will be created in that instance. So in this case here, it deduces basically that these two fields are going to be in a one-to-many relationship. So that's the purpose of enforcing referential integrity, to make that one-to-many relationship. And then now you can go into the description of which ensures that only the information in the customer table can be entered into the orders table. So only if it exists in the customer table will it be allowed to exist in the orders table. Because in a one-to-many relationship, the one side is the main side. You can say that's the original side, the originator. That's the original information. That's the source. And it is being used in the many side. So, as I showed you with this description here, unless it's in the source, it cannot go into the anywhere else. That's not possible. You cannot have no source and then magically making it up somewhere else. That's not possible. And if it is existing somewhere else, you cannot delete the source. You can't delete the source and then it exists in somewhere else. That cannot work. Good. Any questions? Any comments? Any remarks? Any clarification? All right, C. Using the following query design window, create a query to extract the field's ID, first name, last name, phone number, and city from the customers table for all customers from the city of Carnegie, and whose phone numbers are greater than that. Yes, go ahead. Carnage. Once again, using the following query design window, we're creating a query. We need to extract ID. We need to extract first name. We need to extract last name. We need to extract phone number. We need to extract city from the customers table for all customers from the city of Carnegie and whose phone number is greater than that. No comments. Seems you guys had a hard time with this one. All right, so what we have to do is firstly check the boxes. That's the first thing we have to do. Because in a query, these boxes, if you notice the word outside here, it says show, and that indicates whether the field is going to be showed or not. So if it is unchecked, it indicates it will not be shown in the output. So we need to check the boxes for the fields that they want. And if you notice, I checked off at the top the fields that they called. They called ID field, they called first name, they called last name, they called phone number, they called city, and if you notice, they never said anything about street address. So in this case here, we're not going to be checking that box street address. So we're not going to be showing that field. Now, that's just the fields there. We now need to add our criteria. Now, we need to find and city from the customers table for all customers from the city of Carnegie. So what criteria would you put in to get the city of Carnegie? What criteria would you put in to get the city of Carnegie?
Sir, do we put carnage in uplifted commas?
Correct. So simply put the word Carnegie. Is it single or double?
Sir, single?
I think it's double. Query. Where's Georgetown customers? I think it's double. Yes, double. That is double, yes. I think you can barely see it. It looks large enough to be a double. Yes, that is a double. So double quotation mark, Carnegie. But as you saw in the as you saw in this one here, you can put like also. So like. I don't think they would take out a mark if you just put Carnegie in quotation mark. But still, try to remember to put like and the word that you're looking for. So like Carnegie. Now there's another criteria. Whose phone numbers are greater than that? Criteria. Yes, go ahead.
We will put the greater than sign with the phone number next to it.
Good. Now the question is, where are we putting that?
So we would put it in the same box as the carnage.
Good. Why?
Because we are looking for an and not an or.
Very good. So greater than 868-500-00. So we're looking for numbers greater than that. And you're correct. We are looking for a and criteria. Notice the word and. It's in the statement. Customers from the city of Carnegie and whose phone number is greater than. And remember, and criteria is in the same row. If you notice, there's literally a or row. So if it was an or, you would simply put one field in the or row and another field in the criteria row. It doesn't matter which is at the top, which is at the bottom. Once they're in different rows, that's how you get OR. Good. So there is the answer for that. Any questions, comments? If not, D. State the ID of the records extracted when the query design in C is executed. What records will we get? So, like Carnage, greater than that. What record will we get? What's the table though? It's I think it's, yeah, customers table. So customers table. What fields will appear? You can just call the ID number.
ID 6, 7, and 10.
ID 6, 7, and 10. Okay, so all of them have Carnage as the city, but we also have to check the phone number. So remember, we're looking for and greater than 868 500. 868 500. So we're looking for greater than that. So this one here is out because that's 200. This one here is going to stay because that is greater than 500. And the last one, that one's going to stay also. So only 7 and 10 will appear. 6 will be out. So remember the AND criteria, both have to be true at the same time. So it has to be greater than this number and having that city of Carnage at the same time. If it was OR, anyone could have been true and the record would have appeared. All of you clear on that?
Yes, sir.
So records 6, records 7 and 10. Records 7 and 10. Good. And if you notice, they're using a keyword here, record. A record is also a row. That's what we call a row in a table. So an entire row, we call that a record in a table. What do we call a single box? What do you call a single box? One of these single boxes here. That is a field. So a single box is a field. That is the smallest piece of data in a database. So one single box, or you can say one single cell, is called a field. That is the smallest piece of data. And a combination or a row of fields is called a record. And then we basically say that a combination of records is a table. So they're kind of interlinked. You get a field, and then when you group those together, you get a record. When you group records together, you get a table. And when you group tables together, you get a database. That's basically the structure. So field is going to be the smallest, database is going to be the largest. All right, question E, and this is still question 3. The following flowchart shows a repeat until loop. Complete the flowchart by labeling the 2 directional lines, leaving the condition box as true and false. So this is where knowing the rule as to the different loops, whether they start with you exit with a true or you exit with a false, you enter with a true or you enter with a false. This is where that difference, knowing that difference comes into play. So does anybody know?
Where you enter with a true and exit with a false.
So true and so true, false. Technically, technically, true is gonna be over here. There's the output lines. Let me see.
Name of mic. Wait, active name of mic.
Which one is though?
False, then true.
So you're swapping it.
Yes, sir.
So you're saying false over here and true over here.
Yes, sir.
All right. So the repeat loop is a bit simple to understand. It says repeat until. So the until is basically indication that something is true. That word until. So it's like if you're saying keep running until I say stop. Keep walking until it's 5 minutes. So it's kind of like that situation. So it has to be true at the bottom here. That's when you're going to stop. And if it is false, you continue the loop. But let me verify that. Repeat until structure. Yes. So that there was correct. It repeats until a given condition evaluates to true. And that's basically when it is going to stop. Any questions, comments? And say if the repeat loop is this here, then what is the other loop? What is the other loop you gotta remember? Repeat is one loop. What's the other loop?
Sorry, the while loop.
Good. The while loop. And basically, if you remember the repeats, you just gotta swap it now. The while is gonna be the opposite. So if the repeat is false to enter the loop, so basically technically it's false to the top, true to the bottom, then while is going to be true to enter the loop and false to exit. So while the condition is true, you stay in the loop. If at any point in time it is false, you exit the loop. Those differences, see why it's important to remember them. If no questions, let's continue. So draw a flowchart of the while do and while loop in the box provided. Now while do, while, basically the same thing. What are we drawing? How are we drawing? What are we starting?
So the rectangle.
What was it? The
The
rectangle?
rectangle.
Okay, what is the rectangle?
That means the start.
Start. Good. What next?
I think we put the arrows and then do the diamond thingy like.
Arrow, diamond, good. What is diamond?
Condition.
Condition. Okay. Now the first one is actually wrong. Rectangle is not for start and stop. Well, you can see in this example here, it's the oval. Now, technically, yeah, it is the oval. Yeah, it's the oval. The oval is a start and stop. So let me make this a bit smaller. Start. Good. Arrow. What next? So you said diamond, because we're gonna have you said condition, right?
Yes, sir.
Good. So you can say condition, or you can say decision, or you can say question, anyone you want to say. Good. What next?
An arrow again, and then we would have the rectangle.
Arrow and then rectangle. Like that.
Yes, sir.
And
I think it's task for processing.
yes, so that's process.
And then we put back arrow again and an oval for end.
Good. Anything else?
Do we have to put in the arrows too to show how the loop works?
Yes.
Well, we would have an arrow from one of the end of the diamond, the left end, and it's going straight down to the last arrow, midway to the last arrow, I guess. Yeah, like right there.
So what's the direction now? Is it going up or is it going down?
Down.
Down. Okay. Okay. All right. So let's work with that and see what is it. So we said that while something is true, then we enter the loop or we exit the loop. So so start the loop condition. So this here is correct. So we start the loop. We have our condition firstly, that is correct, because we firstly have to test if the condition is true. So this one has the condition at the top. So that's the other difference there. While loop has the condition at the top, repeat loop has the condition at the bottom. So that's the other difference. So that's good so far. Now, draw a flowchart to do a while do and while loop in the box provided. Now, so if it is true, you're going to go down, carry out your process, and then end. But if it is false, if it is true, you enter the loop. It's supposed to loop back up. This here is supposed to loop back up. It's supposed to come back here and go back up. Because if it is true, true means that we're going through the loop. And we have to carry out some sort of process. So coming down here is correct. But this arrow here, let me just clean up here. This coming down here. We can put back the end. Good. So if it's true, no. we won't have the end there. That would be incorrect. This arrow here has to come down and then go back up like this. Because this has to indicate the loop. This is going to be the loop. Let me keep it on this side. So now, so that's true, that comes down there. So let me erase this part here and put it over here to indicate this is true, going down here. Now over here is going to be false, whereby, let me use another color, whereby it's going to come out here and go down to end. Because remember, you want to loop something. So while condition is true, we come down, carry out the process, and then we got to go back up to the decision to test the gain to see if it's true or false. And if it continues to be true, we're going to stay in that loop, going round and round, round and round, round and round. But anytime it's false, you come out and you end the program. So this is how that's supposed to look. Any questions on it? Any comments?
No, sir.
All right. Good. So let's remember those differences, right? While loop has true in the beginning, it's true to enter, false to exit. Repeat loop, false to enter, true to exit. Where's the condition? Repeat has the condition at the bottom of the loop, basically, at the end of the loop. While loop has the condition at the top. The other difference is that the repeat loop has the possibility, not has the possibility, is guaranteed of running the program at least once. That's the other thing to remember. Because the condition is the bottom. It's like, think of it like a gate. You're walking into a building, but the gate is at the end. So you can walk in freely, nothing stopping you, but the gate is at the end. That's how the repeat loop is. But the while loop has the gate at the very beginning, so it stops you. So the repeat loop, you're guaranteed of running the program at least once. Whereas the while loop has the possibility of never running. That's the other difference, because the gate is at the very beginning. It stops you at the very beginning from going in. All right, if no questions on that, going on to F, we're still on question 3. Complete the table below based on the statements in it and the flowcharts in EI and EI 1 and 2. So the flowcharts, this flowchart, that flowchart above, complete the table below. Is the condition tested at the start or end of the loop? So they're testing you right here, that difference. So while loop, is the condition at the start or the end?
At the start.
Start. So that means repeat is going to be at the end. Good, that's correct. While loop has the condition at the start, repeat has the condition at the end. Good. Does the repeat loop execute as long as the condition is true or false? Does the loop, so while loop, what does it do? True or false? When does it execute?
While is true, repeat is false.
Good. So while it is true, it's going to loop. That's the while loop. And repeat. While it is false, it's going to repeat. Good. Statements in the loop must be executed. Yes or no? So this is where the explanation I was given at least once, guaranteed of never run it at all, this is where that comes in.
So while is no and repeat is yes.
Correct. So it's asking if the loop is going to be executed. It's basically asking, is the statement going to run? Is the loop going to run? The while loop, as I said, because of how it is structured, because the gate is at the very beginning, it has the possibility of never running. So that's no. The repeat loop, the gate is at the very end, so you can walk in all the way. So it has the possibility of running. So that's going to be a yes. Now, the number of times to repeat the loop is known. So this is basically asking, yeah, go ahead.
There I'd say no for both.
It technically is supposed to be no for both.
Yeah.
But if you notice, it's asking yes or no. Let me check. What is the question? Number of times to repeat the loop is known. Is the do while loop finite or infinite? In the above code, we have defined a while loop which runs infinite times, as it does not contain any condition. The value of y can be updated to infinite numbers. So it can run to infinity. So basically, do while is that. Do while can run to infinity. So we do not know. Number of times the repeat loop is known. So do while technically is supposed to be no. Is the repeat loop finite or infinite? Repeat loop is infinite. So as you said, both technically is supposed to be no. But it needs a logical condition to stop. Logical condition needs to be specified at the end of the code, which would break the couple. So if it was a case that we had to put yes and no, I would say you'd put no for do while, yes for repeat. But you could test them and put no for both. But I think in this case, they're asking for they clearly say whether if it's yes or no. What is that?
I say yes, it's true.
Yeah, so sometimes the question that CXE pose can be a bit incomprehensible. Yes, any questions, any comments before we move on? All right, so the last one for question 3. State the main requirement. What time are we ending? This can be the last question. This is the only thing you're studying right now. And you're not even contributing to the class. And anyways. State the main requirement for the use of the for loop.
Would that be the count?
What do you mean the count?
Like the number of times you want the loop to be repeated.
All right. So if you were to gut, so like Arima said, so put it in like the appropriate words. So you knowing how many times in advance. So that's the main requirement of using the for loop. So indicating in advance, basically in advance how many Am I saying Arima all the time? Indicate in advance how many times you want the loop to be run. Run or run? Run. Run. To run. To run. Let's work with that. To run. Yes. Indicate in advance how many times you want the loop to run. That's basically the purpose of the for loop. Because the for loop is a finite loop. You would have to indicate how many times the loop should run for. All right, so I think we covered enough information for today. Any questions on anything we covered today? Questions, comments, suggestions, recommendations? Next week we'll do question 4. Another lengthy one. Oh, not as lengthy. It's just question 3. Okay, no comments, no suggestions. All right. That's the end of tonight's class. Enjoy the rest of your night.